trusted brand for discovery and creativity.
The Richardson Craft, training and ideas that build futures.
What used to seem like a really fringe idea is now, well, it feels like a viable option for people looking for something affordable, maybe sustainable, and definitely unique.
Totally.
And for you, the learner, who wants to get a solid grip on a topic like this without getting totally lost in the weeds, this deep dive is exactly what you need.
That's right. We've pulled together a really interesting mix of sources to kind of unpack the whole container home thing.
Oh, yeah. What have got?
We're looking at hands-on accounts from YouTube, channels like Ambition Strikes, The Container Guy, Quantum Tech HD. They give you a real front row seat to DIY builds.
Right. Seeing people actually do it.
Exactly. And we've also distilled key info from beginner guides, like Case Container, practical articles from places like Container Home Hub, and answer the home covering costs and the actual building steps.
Okay.
Even resources like a directory of container sellers and info on design software. Plus, a big overview guide, Shipping Container Homes for Beginners, and a helpful summary from Container Home Hub again.
Okay, so quite a bit to draw from. So our mission basically is to take all this information and pull out the essential stuff, the need-to-knows, and maybe some surprising facts.
Precisely, to give you a clear picture of what it really takes to build one of these.
Covering everything from like the initial ideas and design.
Right through to the actual construction, the costs involved, and the potential hiccups you might run into.
Okay, sounds good. Let's dive in. So first things first, what exactly is a shipping container home?
Well, put simply, it's a house built using those repurposed shipping containers. The super strong steel boxes designed for hauling goods across the globe.
Right, the ones you see stacked up at ports or on trains.
Exactly.
Yep.
And what makes them kind of neat for building is their standard size and shape. It gives you this modular block you can customize in pretty cool ways.
Modular, okay. And they're tough, right? I mean, they have to survive ocean voyages.
Incredibly tough. They're made from corten steel, which actually forms a protective rust layer. So they're designed to be weatherproof, and the steel itself resists rot and mold, which is a big plus.
Okay, no worrying about termites, I guess.
Not in the steel part, no. And you're not just limited to one box. People stack them, put them side by side. You can get pretty creative with multi-story designs.
And there's that sustainability angle too, isn't there? Using something that might otherwise just sit around or get scrapped.
Absolutely.
Yeah.
Recycling these containers is a big part of the appeal for a lot of people.
Right.
Reduces the need for new materials, saves energy.
Makes sense.
And they even have this potential for flexibility. We saw one example, a finished tiny house, 12,000 pounds, being lifted onto a truck by a crane.
Wow. So you could potentially move it.
Potentially, yeah. It's not like packing a suitcase, obviously.
Huh.
But there's a degree of portability that you don't get with, say, a brick house.
Definitely something to think about. But okay, before we get too carried away dreaming up designs, there's a big practical thing we need to mention right up front, isn't there?
Oh, absolutely. You nailed it. Local building codes. Understanding those is like step zero.
Step zero. I like that.
Seriously. What your local council or municipality allows, that dictates everything. It's the very first thing you have to research. Don't even think about buying a container before you know the rules.
Got it. Building codes first. Okay, so let's say you've checked the codes. You're good to go. You've got this image of a strong steel box. Where do you even start turning that into a home?
Right. The first real step is planning and design. You've got to get that layout figured out.
Like how many rooms, kitchen placement?
Exactly.
Yeah.
How many rooms? Do you want it all open concept or, more separate spaces? And really think about natural light and airflow. Where are those windows and doors going to go?
Yeah, you don't want to feel like you're living in a box.
Precisely. So drafting a plan is really recommended. Maybe even talking to an architect, especially one who's actually worked with containers before.
Someone who gets the unique challenges.
Yeah, they understand the modular nature, the structural points, how best to connect things if you're using more than one. They know the design tricks that work well with these long rectangular shapes.
Are there tools to help visualize this? Like software?
Oh yeah, definitely. There's design software out there, things like CAD Pro, Planning Whiz, Room Sketcher. They often have 3D modeling.
Ah, so you can sort of walk through it virtually?
Kind of, yeah. It helps you really see how the space will feel, tweak the floor plan. Some software might even have like container dimensions built in to make it easier.
Okay, design phase is critical. Now the main event, getting the actual container. Where do you find one? And what's the damage cost-wise?
Right, the container itself. Costs can vary quite a bit. You're generally looking at maybe $2,000 on the low end, up to $7,500, maybe even more.
What makes the price jump around so much?
Main things are size, like a standard 20-footer versus a 40-footer.
Which is obviously much bigger.
Right. And height. You can get high cube containers, which give you like an extra foot of ceiling height. Those usually cost a bit more.
Okay, size and height. What about condition? New versus used?
Big factor. You can buy brand new, often called one-trip containers. They're pretty much pristine, maybe made one journey. They'll be at the higher end of the price range.
Okay.
Or you go for used. More budget-friendly for sure, but you might get dents, some rust, maybe even smells or residue from whatever they carried before.
Ooh, yeah, contamination. You definitely wouldn't want like chemical residue in your living room wall.
Exactly. So if you're buying used, inspection is absolutely critical. You need to check it over really carefully.
What are you looking for specifically?
Structural stuff. First, any major dents or bends, especially in the frame.
Yeah.
Rust, is it just surface stuff you can treat, or is it deep corrosion eating through the metal?
All right, big difference.
Sure. Definitely. Check for weird smells, any signs of spills or stains. Make sure the door seals are intact, otherwise it won't be weatherproof. And check the floor, usually plywood, for rot or damage.
Sounds like a thorough checklist. Okay, where do you actually buy them? It's not like there's a container store at the mall.
Huh? No, not quite. You're looking for shipping container suppliers or dealers. Could be local guys, could be bigger international companies.
Local might save on delivery costs, maybe?
Potentially, yeah. And that Container Home Hub site we mentioned actually has a directory of sellers in the U.S., which could be a good starting point for finding someone reliable.
Okay, great resource. So you've navigated the suppliers, picked out your container, had it inspected. Now you need somewhere to actually put it. What about the land and site prep?
Huge step. Finding the right piece of land is key. Obviously, cost is a factor.
Location, location, location.
Right. But also think about utilities. Does the land already have electricity hooked up? Water, sewage access.
Oh, because adding that from scratch can be pricey and complicated.
Hugely expensive sometimes, yeah. And it can make getting financing harder if there are no existing utilities. So land with services already in place is often worth paying a bit more for.
Good point. What about the site itself, the ground conditions?
You need to assess that carefully. What's the soil like? Rocky, sandy, clay. That impacts your foundation choice. How's the drainage? You don't want water pooling around your container.
No moat needed.
Exactly. And how easy is it to get a massive truck and maybe a crane onto the site to deliver the container and materials? Access is important.
Okay, land chosen, site assessed. Now, the foundation. How do you make sure this heavy steel box stays put and stays level?
Foundation time. There are a few common types. You got concrete slab foundations, kind of like a garage floor.
Yeah.
Pier foundations, which are like concrete stilts.
Right, lifting it off the ground.
Yeah, good for uneven ground, minimizes digging. The Ambition Strikes guys used those in one project because they wanted to disturb the natural site as little as possible. Then there are trench foundations, basically concrete footings dug into the ground.
Which one's best?
Depends on your site, your climate, your budget, local codes again. Slabs work well on flat ground. Piers are good for slopes. Trenches offer good stability.
Is this a DIY job, the foundation, or call in the pros?
You could potentially DIY some aspects, but honestly, the foundation is where professional expertise is really, really valuable.
Yeah, I wouldn't want to mess that up.
Exactly.
Yeah.
Getting it wrong can lead to huge problems down the road. Structural integrity, meeting regulations. It's usually best to hire experienced contractors for the foundation. Peace of mind, you know.
Definitely. I remember those Ambition Strikes videos. They had some adventures with foundations, didn't they?
Oh yeah. One time, they were digging the footings before the container arrived, and a gravel truck accidentally drove over some underground pipes, created a whole plumbing headache.
Oh no.
And in that other project, the one focused on minimal site impact, they were using laser levels to figure out height differences, trying all sorts of ways to move the container axles, excavators, even building a sled.
A sled?
Yeah.
Seriously?
Yeah. But in the end, they realized a crane was just the most efficient way to place it perfectly on the piers. Shows the kind of problem solving you might need.
Okay, container is securely on its foundation. Now, the fun part, cutting holes for windows and doors, turning the box into something less boxy.
Right, modifications. And yeah, you're cutting into solid steel, so you need the right tools.
Not a handsaw, I'm guessing.
Definitely not. You're talking a plasma cutter. or maybe an angle grinder with a specific metal cutting disc.
Sounds intense. Safety must be a huge deal here.
Absolutely paramount. Proper PPE, safety glasses, gloves, hearing protection. And good ventilation is crucial because of the metal dust and fumes.
Got it. So tool up, safety gear on. How do you make the cuts accurately?
Measure twice, cut once is the mantra here. Mark out your openings really carefully. Double check everything. Mistakes are hard to undo in steel.
Yeah, no undo button.
Exactly. The Ambition Strikes team, again, they cut some massive holes in a 20-footer for huge windows and a door. They even built this giant frame to hold 2 windows and the door all together.
A frame before installing the windows.
Yeah, they fabricated it separately.
Yeah.
Which actually brings up an important point. Cutting big holes does affect the container's structure.
Oh, it makes it less frigid.
And it can, yeah. They noted that specifically. So that big window frame they built, it wasn't just to hold the glass. It was engineered to add back structural support that was lost when they cut the opening.
Smart. A lot of thought has to go into that.
Totally. They prepped the joints for welding carefully, grinding the edges so the weld could penetrate properly, used specific wire for the thinner frame tubing, even used a laser cut jig to make sure the frame was perfectly square before welding it up.
Precision work. Did they run into problems?
They mentioned the container floor wasn't perfectly level, which made things tricky, and worries about the thin tubing bending during welding, needing adjustments. But it highlighted how cutting openings isn't just about making a hole, it's about maintaining strength.
Okay, so modifying a single container takes care. What if you want more space? Join 2 or more together. Is that feasible for a DIer?
It is, yeah. And there are ways to do it without necessarily being a master welder. The container guy on YouTube showed a really neat method.
Oh, yeah. What did he do?
He connected 2 40-footers using these things called high-capacity bridge fittings. They basically bolt the containers together securely at the corners.
Bolting sounds much more approachable than welding for most people.
Right, much less intimidating. But he also pointed out some structural things to watch for.
Like what?
Like how the container floor doesn't actually sit flat on a slab except at the corners. The main bottom rails are slightly raised.
Oh, okay. So the middle could sag.
Potentially, yeah, once you load it up with furniture and everything. So they welded flat steel bars underneath those rails to give continuous support.
Ah, reinforcing the floor. Makes sense.
And when they cut out the inner walls to make one big double-wide space, they used temporary posts inside to hold everything up and prevent sagging while the walls were removed.
Smart planning. What about the opening between the containers? That's a big span.
For that, they used modular header kits. Again, designed to be bolted together, not welded, which is pretty cool for a 40-foot opening.
Interesting. So bolting solutions exist.
Yeah, avoids complex welding. They even had their electrician install the bolted header because wiring was involved. The bridge fittings also had safety locks to stop them loosening. And then, sealing the joined ridge caps on the roof, a flat bar welded as a threshold on the floor.
Lots of little details to make it work properly. Okay, structure is up. Single or joined? Now, comfort. Insulation seems absolutely vital with the steel box.
Crucial. Absolutely crucial. Steel conducts heat and cold really well, so without good insulation, it'd be like living in an oven or a freezer.
Right. And condensation too, I bet. Metal gets damp.
Big time. Good insulation prevents condensation, which stops rust and mold growth inside the walls. Very important.
So what are the main options for insulating a container home?
Spray foam is super popular. It expands to fill every little gap, creates a great air seal, and has a high R value, which is its insulating power.
Is it expensive?
It's one of the pricier options, yeah. Maybe $1.50, $3 per square foot installed. Both Ambition Strikes and the Container Guy used it.
What thickness did they recommend?
The Container Guy mentioned using 2 inches on a ceiling, but recommended 3 inches for a proper home build. And apparently it's not too hard to trim if needed, like with a hot knife, especially if you're using it with panel systems.
Any downsides to spray foam?
It can be messy to apply. Overspray is a thing. You need to really prep well, cover floors, tape off windows. Otherwise, it can get everywhere and even discolor surfaces.
Okay, good to know. Prep is key. What else besides spray foam?
Rigid foam panels are another common choice. Like InSoFast panels, which Ambition Strikes used, they cost maybe $1 to $2 per square foot.
What's the advantage there?
They help reduce thermal bridging that's heat escaping through the steel frame itself. They're pretty easy to cut and fit.
Any tricks to installing them?
Well, the ideal is often a staggered brick-like pattern to minimize seams lining up. But the Ambition Strikes guys found that containers aren't always perfectly uniform, so sometimes they had to cut panels and fill small gaps with spray foam to get that complete seal.
So a bit of flexibility needed sometimes. What about cheaper options like fiberglass bats, the pink stuff?
Yeah, fiberglass bats are usually the cheapest, maybe $7.50 to $1 a square foot, but they're much more prone to moisture problems if any dampness gets in, and they don't create as good an air seal.
Probably not ideal for a metal structure where condensation is a risk.
Generally, spray foam or rigid foam are preferred for containers. There's also reflective insulation, like foil barriers, which helps mainly with radiant heat and hot climates, often used with other types.
So whatever you choose, getting a totally sealed, continuous layer is the goal.
Absolutely. The Ambition Strikes team even caulked their windows inside and out with 100% silicone before insulating. And the container guy mentioned maybe spray foaming the ceiling before installing joining headers because the foam adds stiffness to the thin corrugated roof metal.
Oh, interesting. Stops it from drumming in the rain, maybe?
Could help with that, yeah. And he stressed doing a walkthrough with the spray foam guys beforehand, pointing out exactly what needs covering, what needs protecting. Sealing every single gap and crack is vital for that airtight thermal envelope.
Okay, insulated envelope sorted. Now you need to actually get in and out and see out. Doors and windows, what are the costs like?
Costs vary wildly here. Windows, maybe $300 to $1,000 each or more. Depends on size, quality, type of glass.
And doors.
Interior doors, maybe $100, $300. Exterior doors, much more, $300 up to $1,500 plus. They need to be secure, weatherproof, insulated.
And like insulation climate matters for windows and doors too, right?
Big time. In cold places, you want windows with a low U factor means they don't let much heat escape. Double or triple glazing helps.
And hot climates.
You look at the SHGC solar heat gain coefficient. You want a low SHGC to block the sun's heat from getting in. Low emissivity, or low E, coatings help with that too.
What about materials? Do aluminum window frames get really cold or hot?
They can, yeah. Aluminum conducts heat more easily. Vinyl or wood composite frames usually offer better thermal performance. For exterior doors, fiberglass or steel often provide good insulation.
So performance is just as important as looks, and installing them securely must be critical.
Totally. You need a good solid frame around the opening in the container wall, and the window or door needs to be installed perfectly square and sealed tightly to prevent leaks and drafts and for security.
I remember the Ambition Strikes guys got those huge windows cheap.
Yeah, great deal on Marketplace. But they were massive, needed that custom frame we talked about. They really stressed getting the frame perfectly square before welding, otherwise the windows just wouldn't fit right.
Must have been satisfying when it actually fit.
Oh yeah, they were pretty happy when that big welded frame slotted right into the container opening perfectly. Shows the importance of careful work.
Okay, structure, insulation, openings done. Now, the guts of the house utilities.
Right.
Let's talk plumbing first. Where does the water come from? How do you handle waste?
Water supply options are usually connecting to the town city water main, drilling your own well, or maybe even rainwater harvesting if you're going off-grid.
What kind of pipes do people usually use inside?
PEX tubing is really popular. It's flexible plastic piping, easier to run than rigid copper, and it resists freezing better.
Okay. And wastewater. Grains and sewage.
Good site drainage is important to keep water away from the foundation, maybe French drains. Inside, you try to plan your layout to keep plumbing runs short, less pipe, fewer potential problems.
And the actual waste, toilets and stuff?
2 main routes. A standard septic system if you're not on town sewer. That involves tanks and a drain field, costs maybe $3,000 to $7,000 usually.
Wow.
Or a composting toilet. Or eco-friendly, uses little or no water, costs maybe $800 to $2,000 for the unit itself.
The Ambition Strikes crew seemed pretty clever with their plumbing.
They were. They used PEX inside with push-fit connectors, but ran copper outside because PEX doesn't like sunlight, UV rays.
Ah, good detail.
Yeah. And they used a specific IKEA vanity that needed a really tight drain setup because of shallow drawers, so they had to find a special 90-degree fitting.
Problem solving again.
Exactly. And instead of a vent pipe going through the roof, they used something called a shore vent, or an air admittance valve. It lets air in, but not out.
Clever. Less roof penetrations.
Right. And in another build, they stressed getting the slope right on drain pipes under cabinets. Even left a gap in a pocket door wall specifically for a plumbing vent.
Thinking ahead.
Yeah, their big thing was keeping all the plumbing inside the warm, insulated part of the house as much as possible to stop pipes freezing in winter.
Smart move. Okay, water's handled. What about electricity? Powering the lights and appliances.
Similar options to water, really. Connect to the grid or go off-grid with solar.
Grid connection costs.
Can vary hugely. $500, maybe $5,000, could be even more, depending how far the power lines are. Plus the cost of wiring the house itself, maybe $1,500 to $3,000.
That's solar.
Panels might be $3,000 to $10,000, depending on the system size. Then you need an inverter, batteries for storage, another $2,000 to $8,000 maybe. So a significant upfront investment for solar.
Right. Either way, you need wiring inside. How do you plan that?
You need a good electrical plan. Think about where every outlet needs to go. Every light switch, every fixture, recessed lights, ceiling fans, smart home stuff, power for the stove, fridge, outdoor lights. Plan it all out.
What kind of wire is typically used?
Romex, or non-metallic sheathed cable, is common for homes. The crucial thing is using the right gauge, the thickness of the wire for the circuit's load. Undersized wires are a fire hazard.
Definitely want to avoid that. And a breaker box.
Yep, a circuit breaker panel with enough capacity for everything, and labeled every circuit clearly. Makes troubleshooting way easier later.
Safety seems even more critical with electrical. Any key rules?
Oh yeah, have a solid plan first. Always turn the main power off before touching wires. Make sure connections are tight and properly done. Don't overload circuits. And honestly, get it inspected. Having a licensed electrician check your work is highly recommended, even required in most places.
Right. Better safe than sorry.
For sure. Remember, the Ambition Strikes guys had their electrician install that bolted header. Shows that sometimes roles overlap, but getting qualified pros for critical systems like electrical is smart.
Okay, utilities are in. Now making the inside actually look and feel like a home. Walls, ceilings, floors.
Lots of options here. For walls, drywall is common and pretty affordable, maybe $1 to $2 a square foot. Gives you that smooth, paintable finish like a regular house.
What else?
Wood paneling is popular too, for a different look, rustic or modern, can add a bit of warmth. Some people use metal panels, plaster. It depends on the style you want.
And ceilings?
Same deal, often drywall or just painting the insulated ceiling. Drop ceilings are an option, good for hiding wires, but cost a bit more, maybe $3 to $5 a square foot.
Flooring, I guess anything goes.
Pretty much. Laminate, vinyl plank, hardwood, tile, carpet, whatever suits your budget and style. The key is prevving the subfloor properly. Make sure it's clean, flat, and level before you start.
Right. The Ambition Strikes guys said they could start drywall once the insulation was done. That must feel like progress.
Huge milestone, yeah. Starting to look like actual rooms.
Okay, inside is taking shape. What about the exterior? Do people just leave it looking like a shipping container?
Some do. Maybe just a coat of paint. But finishing the exterior is common.
Painting seems like the simplest option.
Yeah, relatively easy and cost-effective. Use good quality paint designed for metal. Definitely use a rust-inhibiting primer first.
Does color matter beyond looks?
It can, yeah. Lighter colors reflect heat, keep the container cooler in summer. Dark colors absorb heat, something to consider.
What if you want a more traditional house look?
Then you look at cladding, attaching another material over the container walls. Wood siding, metal panels, stucco, composite materials. Lots of choices.
Does cladding help with insulation too?
It definitely can, adds another layer, and it completely changes the look. Protects the container steel too.
The Ambition Strikes team painted theirs, right? Looked like quite the process.
It was. They had to prep all the welds, pressure wash everything, prime it, then paint. They even had issues with temperature paint. Need specific conditions to cure properly.
Right.
Had to use a heater one day.
And they weren't totally happy with the first color coat.
Yeah, sometimes paint looks different once it's actually on the wall and dry. Happens all the time in home improvement.
True. Okay, so these homes are often compact. Space must be at a premium. Any tricks for making the most of it?
Oh, absolutely. Space optimization is key. Multifunctional furniture is your best friend.
Like sofa beds.
Exactly. Sofa beds, folding tables that disappear when you don't need them, ottomans with storage inside, anything that does double duty.
Makes sense. What else?
Go vertical. Use tall shelving, hang pots and pans. Think about loft beds to free up floor space. Underbed storage drawers are great.
Using every inch.
Pretty much. Modular furniture can be good too, things you can rearrange easily. And don't forget, the outside a deck or patio can feel like an extension of your living space.
Good point. Okay, we've touched on costs all along, but let's talk budget specifically. These are often pitched as affordable, but it sounds like costs can add up fast. How do you budget wisely?
Yeah, affordables is relative. It can be cheaper than traditional construction, but you need a solid budget. Start with a really clear vision. What are your must-haves versus nice-to-haves?
Prioritize.
Exactly. Factor in the container, cost new versus used. Remember that inspection. Land costs, utilities again. And be realistic about DIY versus hiring pros. Where can you actually save money by doing it yourself, and where do you need expert help?
Like maybe you can paint, but hire out the foundation and electrical.
Perfect example. Look for savings with reclaimed or salvaged materials that can make a big difference. But also, budget for the unexpected.
Contingency fund.
Absolutely essential. Permits cost money. Transporting the container costs money. Things go wrong sometimes. You need a buffer.
But long term, maybe savings on utilities, if it's well insulated.
Potentially, yeah. Lower heating, cooling bills. Maybe less exterior maintenance than some houses. So factor that in too. A detailed budget covering everything is key.
Can you get a regular mortgage for one of these?
It can be trickier than traditional homes. Some lenders are still hesitant. Having clear plans, a solid budget, and maybe showing comparable projects or projected value can help. It's getting easier, but not always straightforward.
Okay, another hurdle to be aware of. And speaking of hurdles,
Yeah.
permits and inspections. Sounds like a potential nightmare.
It can be daunting, yeah. It's bureaucratic and not always fast, but it's absolutely necessary for safety and legality.
What do you typically need to submit for a permit?
Detailed plans, blueprints, site plans showing exactly where it goes on the property, maybe engineering calculations proving it's structurally sound, especially with modifications.
And every town or county is different.
Wildly different sometimes. That's why step 0 is talking to your local building department. Find out their specific rules for container homes or alternative dwellings. Zoning laws are huge too. Some areas just flat out don't allow them.
So you could buy land and then find out you can't even put a container on it.
Ouch, yes, that happens. Do your homework before buying land. Be prepared for the permit review process to take time. Maybe require changes to your plans.
Patience and communication are key then.
Definitely. Stay in touch with the permit office. Be proactive. Those daily diary snippets we saw really captured the anxiety people feel about codes and permits, feeling like it's a foreign language, worrying about getting shut down. It's a real concern.
Understandably so. So besides permit issues, what are other common pitfalls people fall into?
Underestimating those codes is probably number one. Leads to delays, extra costs, massive frustration.
What else?
Maybe unrealistic expectations about space or features versus their budget. Thinking they can get a palace for pennies. Unexpected costs popping up that contingency fund again.
And insulation. We talked about how critical it is.
Yeah, skimping on insulation is a big mistake. Leads to being uncomfortable, too hot, too cold, and potential moisture and mold problems. Not worth saving a few bucks there.
And moving them. You said it's possible, but maybe not easy.
Right. The logistics, they're heavy. You need cranes, special trucks, maybe road permits, and you need a new foundation ready at the other end. It's doable, but it's a significant operation.
Okay. Lots to watch out for. But let's end on a positive note. Are there cool examples of people who've made it work, built awesome container homes?
Oh, for sure. Lots of inspiring stories. There was the Johnson family, built a single container getaway by a lake, really focused on solar power, used lots of recycled materials, very energy efficient.
Nice.
And May and her family used 2 containers, made a really vibrant home, got the whole family involved in the design, learned to prioritize what mattered most within their budget.
That sounds great.
Then there was Sarah, who turned one into a community hub in a city. Shows they're not just for remote cabins. And Jack and Emily built a 40-footer in the woods. They prioritized top-notch insulation, though they did hit some snags with local codes initially, but they worked through it.
So diverse projects, diverse people, shows the potential.
Definitely. The reward of creating something so unique and personal can be huge.
So say you've built it, you're living in it. Is there much maintenance? What's the upkeep like compared to a regular house?
It's different, maybe not necessarily less, just different. The main thing is keeping an eye on the steel exterior.
Checking for rust.
Exactly.
Yeah.
Regular checks, especially around welds, edges, any scratches. Treat any rust spots right away before they get worse. Protective coatings help. And making sure water drains away properly from the base is important too, maybe having it slightly elevated.
And future upgrades, can you add on or change things later?
Sure. People add more solar, rainwater harvesting, maybe rooftop gardens. You can always renovate the interior, change layouts, upgrade security, just like any home, really.
Okay, so wrapping this all up, what are the absolute key takeaways for the learner thinking about tackling a shipping container home?
I'd say number 1,
Yeah.
it's a serious project. It takes real planning, understanding the rules, careful budgeting, and definitely some creative thinking when challenges pop up.
But the flip side is pretty appealing, isn't it?
Absolutely. The potential for affordability is there compared to some markets. It's a sustainable choice using recycled materials. And the customization. You can really create something that's totally you.
And yeah, it won't always be smooth sailing. We heard the anxieties, the potential pitfalls, but seeing those success stories, the reward seems pretty significant for those who pull it off.
Exactly right. That feeling of building your own unique space. So the learner, maybe the final thought is this, seeing the ingenuity involved here, using these strong industrial boxes. What other unconventional materials or approaches might hold promise for future housing?
Interesting question.
Yeah, maybe it sparks some curiosity about exploring other sustainable building ideas, the tiny home movement, different ways to reuse materials. Who knows what the next cool housing innovation will be?